P represent a false statement and let Q represent a false statement. Find the truth value of the given compound statement. So first, let's just talk about what it means to construct a truth table of a compound statement. So the compound statement that we have reads P and not Q. And to understand what this means, we must first understand the definition of negation and conjunction. So the negation of a statement reverses its truth value, which means if we start out with a true value, when we negate it, it then changes to a false value. Conjunction expresses the idea of and. A conjunction is true only when both component parts are true. So let's apply that to our truth table here. We always start the truth tables with our P column, which gives us true, true, false, false, and our Q column, which gives us true, false, true, false. So this is how we're going to start with our truth tables, right? That's going to be a given. So then we begin to fill in the blanks. First, we'll fill in the blanks for not Q. That means we go to the column for Q and we negate each of these values. So we have T, we negate T, that means F, right? So true means false. False is true. True is false, and false is true. So we've negated Q, right? T went to an F, F to a T, T to an F, F to a T. Now we want to look at the entire compound statement. And remember, a conjunction can be true or is true only when both component parts are true. So we are comparing P, so the column of P, and not Q. So here's how we complete the values for this compound statement. We have true, false. That would be false for this conjunction because, again, it can only be true when both are true. Next, we have true, true. So, of course, that means it's true. Both component parts are true. The value is true. We have false, false, that's false, and false, true, that is false. So that's how we complete the entire truth table for this compound statement. But now we want to take a look at the actual question that was asked. P represents a false statement and let Q represent a false statement. So where P is false and Q is false is here, right? P represents a false statement, Q represents a false statement. And so what that means is in our truth table, when we compare P and not Q, we compared P and not Q, which gave us a false statement, right? So it's a little interesting how the question is asking us to look into the truth table a little deeper. So let me go back. The question is asking, we're not looking at the entire truth table. We just want to look at when P is represented with a false statement and Q is represented by a false statement. What was the outcome of that compound statement? So when we compared P and not Q, it is a false statement. So the answer is false.